Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the law of floating of any object in liquid. So first of all, let us discuss the meaning of this word floating. So floating exactly means that an object which is floating in the liquid or in any fluid has buoyancy acting on it in the upward direction, and it is balancing the downward forces. So obviously if this system is at rest, so the buoyancy will be balancing the mg acting on the block, and therefore we can say that for floating the net force will be zero. If the buoyancy is acting in the upward direction and it is mg is acting in the downward direction, then we can say that buoyancy will be balancing mg if the block is floating, and buoyancy will be V immersed into density of liquid into G, and mg will be V total into density of solid into G. So cancelling G with G, Vi by V will be equal to sigma by rho. And if the area of cross section of this block is A, then we can say that Vi will be A into Hi, and V will be A into H, and it is equal to sigma by rho. Cancelling A with A, Hi by H will be equal to sigma by rho. So we have to remember these two expressions, and we can conclude, we can say obviously that if sigma is less than rho, then if the density of solid is less than the density of liquid, then Vi will be less than V and Hi will be less than H, which means that solid will float in the liquid partially. Now the partially word means that some part of that solid would be outside the liquid and some of the solid will be immersed in the liquid while floating, and obviously buoyancy will be balancing out the mg, and net force acting on this object will be zero. Now if sigma is equal to rho, then Vi will be equal to V and Hi will be equal to H, which means that it will float while immersed completely. Now it means that this block, let us draw a block, and this block will be floating inside the liquid completely, which means that its head, its top would be inside the liquid, but this would be floating also, floating only because obviously the buoyancy will be balancing out mg. The only difference in this condition and in this condition is the fact that now the buoyancy which is balancing the mg requires the complete volume of the solid to be immersed inside the liquid. So this is a condition of floating only. But if we say that if the density, now let us also discuss a practical example. So we know that the density of ice is equal to 0.91 times the density of water, which means that if we know that density of water is 1 gram per cc, and hence we can say that the density of ice would be 0.91 gram per cc, which means, and this difference of 9%, this is 9% difference, we can say that density of ice will be equal to 91% of density of water. Now this difference of 9% is due to the open cage structure of the ice, in which their air pockets are there inside the ice due to intramolecular hydrogen bonding, and due to that air presence inside the ice, the density of ice is 9% less than the density of water. And hence we can say the glaciers which are floating inside the oceans or in water, we can conclude that volume immersed upon volume total of that glacier will be rho ice by rho water, and the ratio of rho ice and rho water is 0.91. So we can say that Vi is equal to 91% of V, which means that the 91% of volume of glacier is inside the liquid, inside the water, and only 9% is outside the liquid water. So what volume of glacier we are watching above the level of the water is just 9%, and the 91% part of the glacier is inside the water while it is floating. Now let us also discuss the sinking condition. So if sigma is greater than rho, then obviously Vi will be greater than V. But this is not possible, and again this condition will also not be possible, because in this case net force will not be zero, and the net force will be acting on the downward direction on the block, because net force will be equal to mg minus buoyancy. Okay, and in this case block will sink down to the bottom. Block will sink down to the bottom. So this is very important to note, that this block will sink down to the bottom if sigma is greater than rho. But if we are discussing the law of floating, so law of floating says that for floating sigma should be less than or equal to rho. This is the condition of floating. So guys, this was it in this video, and in the next video we'll be bringing some amazing concepts of buoyancy. Thank you.